In homework 9, the next problem that we're going to tackle is understanding the common modes of radioactive decay. And in this problem, you are being asked to either predict a nuclide or predict a decay mode or predict a daughter nuclide, and that's using some terminology that we haven't used so far. So just to give you understanding of what is meant by the nuclide and the daughter nuclide. The nuclide is basically our reactant, and the daughter is the product of the reaction. And there are 4 different reaction types, or as this problem is calling them, 4 different decay modes that the nuclide can undergo as it converts to the daughter. So one type is called alpha emission, and in the alpha emission reaction, we have our nuclide that is giving up an alpha particle. Let's just write that out. Giving up the alpha particle and producing the daughter. The other type number 2, is beta emission, which is really similar. We have our nuclide, and it is giving up a beta particle to produce the daughter. And then we also have positron. Remember, the positron is basically the opposite of an electron. So this is a nuclide giving up a positron to produce the daughter nuclide. And then last but not least, we have something different called electron capture. So this is not an emission process. This is where the nuclide is catching a free electron and using that to convert into the daughter nuclide. And this process spits out a lot of energy in the form of gamma radiation. So that gamma radiation is always listed as one of the products of this type of reaction. So let's take a look at how we can apply this to this ALEKS problem. First, we have a nuclide, hydrogen 3, and it says it's undergoing beta emission. So what is that product going to look like? Actually, I'm going to want to write this stuff down too. So if we know we're undergoing beta emission, then it's going to be helpful for us to think about the beta particle as a product of the reaction, and that's going to help us fill in what our daughter nuclide would look like. So we know that the mass number of the right side of the equation needs to add up to 3, which means that whatever this nuclide is, it's going to have a mass number of 3. And we know that our atomic number, it needs to add up to 1. So whatever our total atomic number is, it has to add up to 1. So this means we need to have an atomic number of, I'm doing okay. So this would be a helium 3. For the second problem, we have our nuclide 238 uranium, and we know that we're converting it into 234 thorium, and we're trying to fill in the missing piece here. What is being emitted? In order to balance this equation, we can see that this is going to need to be emitting an alpha particle. So this is going to be an alpha emission decay. And then our last example on here, it says this is an electron capture reaction. So that means that we are going to be adding an electron. And the product, the daughter nuclide, is going to be lithium. And we know that we're also going to be making some gamma radiation, even though there isn't a spot for us to fill that in. So here our job is to try to figure out what the nuclide originally is. We know that our mass number needs to be 3. So over here we need to have a total mass number of 3. So this guy's, I'm sorry, I'm saying mass number, I mean atomic number. This guy's atomic number needs to be a 4. Our mass number needs to be a 7. What is element 4? Atomic number 4 is beryllium. So this is going to be beryllium 7.